everyone, Sherry Ann here, and welcome to mychemistryhub. And today we'll be doing a past paper. This is CSEC past paper, and we're doing organic chemistry. So let's get into it. So the question reads: two organic molecules, compound D and compound E, are shown below. Right? So we're seeing compound D here and compound E. Now, if it reads, compound D inhibits the growth of mold and bacteria and is used as a preservative in the food industry. Right? Then it simply asks us the first question: state the name of compound D. Now we've seen here that compound D has a carboxylic functional group, and it has three carbon atoms. So 3 carbon atoms, the prefix would be pro. And because it has a carboxylic functional group, the suffix would be ANOIC. So the name of compound D is propanoic acid. Simple question. Identify the homologous series to which compound D belongs. We already stated this, right? So compound D belongs to carboxylic acid homologous series. Or sometimes it's called alkanoic acids. The same thing. State one chemical property of compound D. Now, one chemical property of compound D is that it's soluble in water. Now, due to the presence of this hydroxyl group right here, hydroxyl group, compound D is soluble in water. Carboxylic acids are soluble in water because they're polar in nature, right? But the thing is, as the number of carbon atoms increases, the solubility decreases. So methanoic acid, ethanoic acid, propanoic acid, all soluble in water. But as you increase the number of carbon atoms of butanoic acid, pentanoic acid, hexanoic acid, the solubility decreases. They're not so soluble in water. All right, so part B says compound E is present in alarm pheromones that are produced by honeybees. So compound E, let's take a look at that. So they ask us, questions D, state the name of compound E. So compound E, of course, is an alcohol because the functional group OH is present here, and it has 4 carbon atoms. Now, 4 carbon atoms, the prefix is but, and because it's an alcohol, the suffix and the prefix. So the name of compound E is butanol. So, of course, the prefix is based on the number of carbon atoms present in the molecule, and then the suffix is based on the homologous series or the functional group that is present, right? So compound E is butanol. It says also to identify the homologous series to which compound E belongs. I already stated this, alcohols. And write the general formula for this homologous series. Now, the general formula for this homologous series is CnH2n+1 OH. Now, this was butanol, so C would be 4, because it has 4 carbon atoms. The number of hydrogen atoms would be 2 times 4, right, plus 1, and OH. So it would be C4H9OH, and that would be the formula for butanol. That's your 1 mark. Simple. All right, so moving on. So compound F and compound G shown below are hydrocarbons. Hydrocarbons, compounds that have carbon and hydrogen atoms. State one physical property that is common to both compounds F and compound C. So let's see, what is compound F? So compound F is an alkane here. You can know that it's an alkane because it only has carbon single bonds, yes. And compound G is an alkene. You know it's an alkene because we have a double bond present here. Carbon-carbon double bond. Now, one physical property that is common to both alkene and alkenes is that the boiling points increase with the molar mass of the compound. The boiling point increases with the molar mass of the compound. So as the number of carbon atoms increase, the boiling point increase. Also, both are insoluble in water. Just to name another one. Both alkenes and alkenes in water. Now, part 2 says, state which compound F or G will react with bromine in the dark. This is important. Now, compound G, only alkenes undergo a rapid addition reaction with bromine or with halogens in the dark. Rapid addition reaction. So that'll be compound G, alkene. So only alkenes undergo addition reaction, or they can react with bromine or with halogens, for a matter of fact, in the dark, with reaction with bromine in the dark. Alkenes, they can react with bromine or halogen, but UV light has to be present. So that's why I said that the condition here is important. So in the dark, only alkenes can react with bromine. So now it says, draw the fully displayed structure of the product that is formed from the reaction in C2 above. So that's the reaction between the alkene, which was, now this alkene is butene. We didn't name them, but let's name them. 1, 2, 3, 4. So you know it's 4 carbons. Presence as a double bond. You know, ene would be our suffix, B would be our prefix. And of course, 1, 2, 3, 4. B would be our prefix, ANE, because we're dealing with an alkene. So we have butene, compound F, butene, compound G. So when butene, nope, not there. It's there. When butene, let's draw this out. Right? So that's butene there. When butene reacts with bromine, we stated before that it undergoes an addition reaction, right? So what happens is that this double bond here is broken. Double bond is broken, and the bromine atoms are added where that double bond is broken. Let's use another. Let's get this. The double bond is broken. This is our product here. So the double bond is broken, and the bromine atoms are added to the carbon atoms right there where the double bond was. So the double bond, we're seeing double bond was here. It's broken, form a single carbon single bond, and the bromine atoms are added. So this is an addition reaction. All right. And of course, this is 2, 3, 2, 3. So we use commas to separate numbers. We use hyphens to separate the numbers from the letters or the name itself. So it's 2, 3, di, because it's 2 bromine atoms. Dibromobutane. 2, 3 because the bromine atoms are on carbon numbers 2 and 3. So 1, 2, 3, 4. 1, 2, 3, 4. So going right or left, the bromine atoms would be on carbon numbers 2 and 3. So it'd be 2, 3 dibromine because it's two bromine atoms, bromobutene. Okay. Now to the last question. It says, will compound F burn in air with a clear blue flame? Yes, it will. Let's change this back. Compound F, which is an alkene, will burn in air with a clear blue flame. Right? G, which is alkene, compound G, which is an alkene, right? It burns with a smoky flame. Now, the reason why it burns with a smoky flame, that's compound G. G, so it would burn with a smoky flame instead of a clear blue flame, is that the ratio of carbon to hydrogen in alkenes is higher than in alkenes. So the carbon atom to hydrogen atom ratio in alkenes is higher than that in alkenes. So therefore, when they burn, they release the unreacted carbon as soot. So that's why you have this smoky flame instead of a clear blue flame like alkenes. Then it says to write a balanced chemical equation for the reaction that occurs when compound F burns in air. Compound F, formula C4H10, when it burns, which is a gas. Of course, we have to put our state symbols. When it burns in air, or it undergoes combustion, it forms carbon dioxide, gas, and water as steam. Right? Are we balanced? No, we're not. So always remember to balance your equation. Okay, yes, let's write that properly. So plus 10H2O, and that's a steam, right? So butane burns in air or in oxygen to produce carbon dioxide and water as steam. So it says state two properties. The last question says state two properties of hydrocarbons that make them good fuels. Hydrocarbons, as was stated before, are compounds that have hydrogen atoms and carbon atoms, right? Only. So one property that makes them good fuel, that they burn easily when they're ignited. You know, that's one property you want in a fuel, it burn easily. And also they release a large amount of energy when they undergo combustion. They release a large amount of energy when they undergo combustion. Combustion, of course, is when they burn in air oxygen. Right? And that completes our past paper for today. I hope it was really good and you learned a lot. Ensure that you subscribe to our channel and also follow us on all our socials, and look out for our new videos each week as we journey to CSEC.